Started, yes. All right, good. So we want to working out a valid date. For those of you all who started to write pseudocode algorithm, many of you all started well by deciding to ask the user for input. Okay? So we have print, or let's say we have int, month, day, and year. And these are my variable names. I just, name them like that, right? So we said here printf, not printf, print, sorry. Print, enter your date. And the next thing that we do is that we input date. Sorry, not date, but day, comma, month, comma. Yeah. All right. I have 3 Ds today. We start off well. We agreed that the first thing that we might want to do is to ensure that the first thing that we want to do is to ensure that the months fall into the range 1 to 12. Yes? So we're building. So we say if month is greater than or equal to 1 and month is less than or equal to 12, then what do we know? I just kind of go in with something here. I'll change it as I go along. But we know that so far we're in the realm of valid, right? So we could say print valid. I'm going to change this. I'm just going along with it for now. Else, print. I wouldn't suggest you write anything that I have on the board until it's close to complete, and because I will be changing some stuff. So far we've validated for months, yes? Do we have to worry about month in any capacity again? Yeah, but only in relation to the amount of days, right? But we know in terms of a month being entered, it has to be between 1 and 12. That's what we're saying here. Yes? Right. I would extend this a little bit and say, and year is greater than 0. Okay, so once the year is greater than 0, 1, go up. It could be anything bigger than 0, right? Did we have a year 0? Right? Right. So, okay. We could argue whether or not 0 is a valid year or not. Okay. So, whether we have a greater than sign or a greater than or equal to sign there, we could dispute that. But again, this is still a valid date. So, if I enter, I'm not studying the day right now, but once I enter something inside of year that is 1 to 12, sorry, yeah, in month, thank you. That is 1 to 12, then it's valid. Once I enter anything in year that is bigger than 0, then it's valid. So good, we have a baseline validity. We can move forward now and start to look at specific months. So I'm moving this print valid here. And I'm going to say if what? I'm not going to start with the hardest month. Okay? And I'm gonna say something that I know, I'm probably gonna regret in the future. But, be like a good program. Good programmers are lazy. Good programmers always find a way to do the easiest work first, and then, the hard work will take care of itself later. Right? So, now when you're arguing with your parents, don't go and say, hey, Mr. Valder says it's a good thing to be lazy and cleaning my room today or nothing. So, don't call my name. Right? Yeah, right? Your parents looking for me and all kind of thing. I'm not up for that. So, I'm ready to throw sir and that bus. Their parents calling my phone. It's like, well, why so and so not doing this? And no. Alright. So, we say, if what? We do the first 4 months for 30 days. So, if month is equal to 4, or month is equal to 6, or month is equal to 9, or month is equal to, 11. Now notice something about my statements. Notice something about my statements. My statements are joined by the or, but what is the or joined? Each one of them is a complete conditional statement that will return true or false. Okay? So in the case of, let's say, month having the value 7 entered, I will get if false, or false, or false, or false. And if false or false or false or false, it means that we don't do the statements controlled by that if. The statements must be complete. I don't want to see equal to 4 here, and then you're not putting back the variable names there. It's entire statements. Okay? So that's one thing that we have to get used to. And again, let's just check it with a value of 6. If is equal to 4, so we'll end up with false or true or false or false. But what do we know about the or? At least one has to be true. So we could have a million false and 1 true, and it becomes true. So this statement here, once these months are good, we want to check these months for a certain amount of days. Yeah? So, how do we do that? We say, if day is greater than or equal to 1, and day is less than or equal to 30. So if day is greater than or equal to 1 and day is less than or equal to 30, then what happens? Then this is, we could print valid date. Okay, we end this if, we could have else, print, keep on going to C, boy. All right. Alright. Otherwise, we print invalidate. And then we end the if here. End if. Invalidate. So what do we have here? What we have here is this block complete. Okay, what we have here is just the 30 days for a 30-day month, right, for any year greater than 0. That's the condition that we have complete. We could validate against that. We could validate against April, September, June, or November. Now we want to go and validate against the other months here. We want to go and validate against the other months here. So, Yes.
So if we put it up here plus, if none of it has to be true, right? You're printing invalid, right?
Mm-hmm.
Repeat? Like, okay, so how it is written there, if it is not valid, it will print that the date is invalid, right? So if we end, wouldn't that be ending off the analyzation there? Because it will print that the date is invalid instead of going and check for other criteria.
Only for where the months are concerned, yes.
Okay.
Right? But remember, for any other month, it will check in its own branch. So this is where we are at, is assuming that the year is fine, and the month is fine, and the month was 4, 6, 9, or 11. But then no other branch should check where the month is 4, 6, 9, or 11. This is where we would have had to check for that. So we come down to checking for the date in that instance. And yes? Where? Inside here? Yeah, we're going to do that now. Right? So we're going to put an else if. Right? So it's a nested if else if basically. The end if? Right. No, because we would not have been allowed in that branch if the other months were provided. Yeah, it is essentially you have to pass this gate to be able to check those 1 to 30 days. All right, so we're coming out and we back underneath here. Now look, and again, this is why I stress indentation. Because look where I'm going to put this else if. Else if. Else if what? Else if month is equal to 1 or month is equal to 3 or month is equal to 5 or to 7 or month is equal to 8 or month is equal to 10 or month is equal to 12. Okay? So, and again we fall into a nice little trap that programmers fall into. By trying to be lazy, I've had to type out that whole statement. Right? So sometimes you shoot yourself in the foot either way. But that's fine, because the logic under those months are easier to work out than the logic under the month of February. So I kind of had a little trade-off there. Okay? And for underneath these months, again, we could just simply copy and paste the condition and change it to 31. Yes. You are a programmer. Right? And look, boom. We have 11 months of the year done. It feels like what you were writing in your book, right? It just feels a little more structured. This is where anybody feels like if the brain wasn't here?
It's so weird that I have that.
Not in this format.
Yeah, but I have everything there.
Right, and that's what I see with most of what you all had, that you were thinking like this, but the reality is, huh? Exactly. Okay? So, and again, this is exactly what you had. It's just that you weren't asking me, like, is your month 12? You were just telling me the month has to be 1 or 12 or in between. Right? So it was more like you needed to just ask in the narrative questions rather than to give statements. So that's why I told you were real close. Right? So we have 11 months sorted out. 11 months, easy. Now for February. February. Alright, this painful month. February. Anybody here born in February? If you're lucky enough, I was going to tell them something troublesome. Alright? Some of the people is going to misbehave here. If it was a thing, it would not be true anyway. February people are just as good as every other month, but just not as good as December people. Alright, see? Alright. If it's for December, raise your hands. Yeah, right. So September, the month that school starts, nobody. Alright. February was good as of 2021, where carnival stuff happening. So, yeah, no. Maybe February could redeem itself next year. Huh? Right, you see? So, alright, okay, let's get back into the last one. Yes? Yes, because this end if here ends this if statement that started up here. But this if statement was still open. Remember, every if needs to have an end if. Right? So this here, this end if, is related to this if. And that's why, again, it's because of the indentation and having it in line with each other, it tells you which one belongs to the other. Okay? So, again, so this if is with this else if, and we are now about to put an else here. We don't have to say else if month is equal to 2. Because prior we validated that the months are only 1 to 12, and we already eliminate 11 months here. So the only thing that it could be inside here, given how we structured this thing, is February. So we don't have to say else if month is equal to 2. Understood? Mm-hmm. Repeat that question. Right. The last else? No, it would have to be an else if. So it could be an else if without a final else. So if you have 3 specific conditions that you want to do something for, and all other conditions do nothing for, then drop the last else. But if it is that you want a catch-all statement, then you have to put just the word else. And in this case, it just so happens that catch-all is just 1. Understood? So this is just this case that else just catches 1. And it is the same as if you had put else if m is equal to 2. And you could have put that, but then at the end of that logic, you would have just put the end if. Because there's nothing else to catch. Understood? No, you can't. If you have the word else means all other possibilities. Yes. So if it is that we were ambitious and decided to get February logic out of the way, we could have if month is equal to 2, else if month is equal to 4, 6, 9, or 11, else. And in that case, you would have catch about 7 months or 7 months. Make sense? Right? So yeah, it is that, again, the laziness kind of caused some misuse here. Yeah. All right, so we have else. Now for February, we have some conditions. Our conditions are that we can have either leap years or non-leap years. Right? We know what the conditions for leap years are. So let's write that out. We can say if, I'm going to just bring this up a little bit, right? So, right. We can say if what? If year, right, mod 400 is equal to 0 and year mod 100 is equal to 0, right? Let's pause there. This is a condition in itself. This is one of the two leap year conditions. And they have to be together. Right? So it has to be that the year is divisible by 400 and the year is divisible by 100 for it to be a leap year. Or what? Or the year is mod 4 is equal to 0 and year mod 100 is unequal to 0. So what does this tell me here? This tells me that the year is divisible by 4. The year is divisible by 4 and it's not a century year. So these two things must be together and it's one of these two things. Understood? Anybody not feeling? Go it over? No? Everybody's happy with it. Because it's what we spoke about. And now we know that for this condition, what days could we check for? 1 to 29. So we can say now, if day is greater than or equal to 1, and day is less than or equal to 29, what do? We print valid date, else we print invalid date. So we print valid date, else we print invalid date. Yes. So we have now an else. In all other cases, else, yeah, we do this, we take the same approach here. Yep. 28. And there we go, end if here. And this end if was for this check-in with the year mod 400 and the year mod 100, or year mod 4 and year mod 100 is equal to 0. Right? And, well, right. And we had that from down here, else print invalid date. We kind of did that from early. Right? Because this here will stop our program or print invalid date if we enter a negative value for year, or we entered a value that was outside of 1 to 12 for months. So we can now go ahead and kind of just give ourselves a couple different dates and check and see our logic, whether or not our logic works. Yes? Yeah. Hmm? No, the remainder is equal to 0.
And then you have 4, the other ones, right?
Mm-hmm.
You never check to see if it's just a normal year. So it was just...
Yeah, the else is for the normal year. Let's check it and see. This is why what's your name again? Huh? Right, Emmanuel. What Emmanuel doing is actually recommended. Right? You question things. I honestly, I kind of, Emmanuel, I'm not sure it's going to work. Right? But this is the reason why we test. Because we write something that we are confident in enough to test. And if our test fails, then we could modify the code. And you have to be able to do this in the exam too, in that time that we have. You write down something and you come up with a few cases and you say, let me just run it through and make sure the code that I write isn't suspicious. Okay? So we are at a place well enough where we could test it. Alright? I have enough confidence in it to test it. Alright, so let me see. Good. So let's enter a date. Let's enter the 29th of February 1983. That's a weird looking tree. That's no better as a tree. Alright, we know it's 1983. Stop judging me. So we go in. We start off at the top with month. Is the month between 1 and 12? Yes. So we know that we can enter into this second if structure. We go, is the month 4, 6, 9, or 11? No, so we go down to the next if. Is the month 1 or 3 or 5 or 7 or 8 or 10 or 12? No, so we go down to the else. Yeah, so we fall into the catch-all for the month, and now we're checking to see the date for the month. Alright? We have 1983. 1983 mod 400. Huh? It's what? It leaves a remainder. Right? It leaves a remainder of what? 383. So this was false. Is the year mod 100 equal to 0? No. So this is false. So we have the first part of the stuff surrounded by the or false. The year mod 4 is 1983 divisible by 4. No. So this is false. Is the year mod 100 in equal to 0? Yes. That's true. But false and true gives us false. And false and false gives us false. And false or false will give us false. So then we have to fall into the else. Right? We fall into the else for 1983. And the thing is now that the date is 29. So we're saying here, is day greater than or equal to 1? That's true. Is the day less than or equal to 28? That's false. True and false will give us false. Invalid date prints out. This is an invalid date. The 29th of February 1983 does not exist. Okay? So, anybody else? Give me a date. The 14th of the 7th, what year? 14th of the 7th, 2004. It sounds like a birthday. Alright. We want to check it against our date picker. Alright, so our date validator. So the 14th to the 7th is our month within range. Yes, our month is good. Alright, what month is it? Is it 4, 6, 9, or 11? No, so we fall into the second set. Okay? So this here will give it true, while the others are false. So it's all joined by ORs. We know that once we have one true, then it's true, so we fall into here. Does the 14th fall between the 1st and the 31st? Yes, this is a valid date. You were born on a valid day. Alright? It would have been crazy if we had found out that your birthday was a date that doesn't exist. Okay. What if we had like broke reality and she just stayed away in front of all of us? You know? Alright. So, Emmanuel, let's think of a date. We check in. What date can beat this date validator? So do you now have faith in my code? Oh, this statement here. Oh, okay. So okay. Fair enough. Right. So let's see. Yeah, that's a good one. The year. So let's say that we have the 12th of the 12th minus 2. Okay? And, you know, if one of the older teachers were walking around, I would have said that that's when they were born, but, you know. Alright? Well, I feel like if I'm old enough right now for you all to feel that this is my birthday or something, so. Alright? Oh, crap. Yeah, alright? Well, that lets you know the extent of I was born outside of time. You all don't want to mess with me. Okay? Alright. Huh? If I put a snail, I have no idea what you're talking about. Alright, so we're going. So the month, we check in from the get-go. We have the month is greater than 1, so this is true. We have the month is less than or equal to 12, this is true. And the year, however, is not greater than 0. So this is false. So no matter how you go with it, because we joined everything with and, everything must be true. So we don't even jump into this. We go straight to this else, which then prints out invalidate. Because the else is part of the if structure. So it's more like end if structure. Right? Not just really just the end if, but the else and the else ifs are part of the if structure. Right? But who want to type out the word structure at the end? Hold on. You have to talk a little louder. What? 30.25. Oh my, 30.25. What's going to happen off the bat is because of the fact that we've declared these as integers, even if you enter the value 30.25 of December, right, 1990, what you're going to get is that this is going to adjust to 30. Well, depending on your language, right? Because we say that integers, they are designed not to hold any floating point value. Then you're wicked, because you're dealing with... that is a programmer problem. There is no 30.25 of any month. You got you getting into the realm of philosophy. And that's huh? Right. Okay. Yeah. Right. And that's why you get the 4 every 4 years you get the extra day. Right. But that is again we have days as a year is 365 and a quarter days long. So that's why just less than a quarter day long. So that's why every 4 years you get the extra day because the 4 quarters add up. But every 400 years is when you go long enough that the quarters don't add up to an extra day. So, sorry, they add up to an extra piece of the extra day. No, 400. That's why we have on the century years, every 400 century years you get a leap year. Listen. Some really old astronomers worked this out long ago. Well enough for you guys not to have to worry about it now. Huh? No, it drops the whole. It drops the whole floating point. So no. The integer is designed to only whole value. So it doesn't matter if you have 0.999, it'll drop that. Right? So if you have 30.999, it's 30 when you convert it to an integer. Huh? Oh my gosh. Then you're going to have to program that BC into existence in your program. Well, yeah, true. It could be, yeah. So, it's not 0. And 0 actually is supposed to be a year, I guess. So.
No, but then, we realize currently, right? Currently, I'm talking about, we're talking past.
Yeah.
We don't count a piece of a day.
Well, that's what I'm saying. So we just kind of hold the day in an account until the leap year comes around. Guys, everybody, stop making this more complicated than it has to be. It's probably 30 seconds of 12. Alright. So we have one last day. Just so we have one last day, the 32nd of the 12th, 2020. Alright, so let's just check and make sure. One last request. The 12th is valid, so and the year is valid, so we will go there. Alright. We have the 12th falling into this second section here. Okay, so we got the 12th being true here. And we say if the day is greater than or equal to 1, which is true, and the day is less than or equal to 31, which is false, so we end up printing invalid day.
We check all sections.
Yeah. All sections have been checked. Any questions other than ones related to the piece of a day that add up every 404 years? Alright. No? We good? Alright, good. So, it's 1:30. I am caught between introducing the looping and asking us to do this as a flow chart, and I feel that the flow chart is this as homework. Okay. Huh? Yes, your flow chart is this represented as a diagram. Well, you see. Yes. Yeah. Yes. Yeah, you can go ahead. Bye. All right. So we have this as a flowchart to do for homework, okay? All right. Somebody message me and remind me to put it up on Microsoft Teams so you all can submit it. Mm-hmm.
Right. So you put in.
Yeah. Yeah. You might just have, no, you just make it large. Alright, just make it large. But yes, the decision box is gonna have a long the whole else if. What's in between here? This will go inside. This statement will go inside the decision box. Alright? This statement here will go inside the box. But then remember the box has branches. So you're branching off. If this is what will branch off for true, you're going to another decision box, and then you have an input-output box. Alright, listen, these are the fundamental things that we have to do. Okay, so it becomes very, very easy very, very quickly. Trust me. But you have to just do it. You have to attempt it. Okay, so this is one of those. The more you practice it, the easier it becomes. Yeah. I only have 5-minute bio break. Yeah? Yeah? Right, okay.